Hello all, a very good day to all of you. In this session, we will discuss all the questions that have come from analog circuits in 2019 GATE examination for electronics and telecommunication branch. Okay, so in 2019, right, there are many questions actually. So 2 are of 1 marks and 7 are of 2 marks. Okay, so total 16 marks have been asked from this particular subject. So if you see, the weightage is more. So let us solve all the questions one by one. The first question is, in the circuit shown, A and B are the input, right, and F is the output. So we have to find out the functionality of the circuit. Okay, so in order to find out the functionality, let's build a truth table, right? So if you know the truth table, I can know the easily the functionality, right? So let's take two input, A and B, A and B. This is my output F. So I have to find out the output in all the variations. Input is 0, 0, 0, 1, 1, 0, and 1, 1. So in all the combinations, I have to find out the output. Okay. So first let's take this one 0, 0. So if A is 0, right, and B is 0, right. So if A is 0, this is 0, right, this is 0, B is also 0, that means this is also 0. So this is 0 and this is 0. Okay. You see, since gate is 0, right, this is off. Since gate is 0, this is off. Okay. And this is PMOS, right? Since gate is 0, I have VSG is VDD. Here also I have some VSG. So both are on. So both are on. So we will treat it as like a switch, right? So VDD will come to the output. So VDD means I can say 1. So in digital, 0 means 0 volt and 1 means VDD volt. Okay. So F is 1. So let's take the another condition. Another condition is, okay, A is 0, B is equal to 1. 1 means I can say VDD, right? So since A is 0, this is 0, and this is VDD, right? And this is also VDD, right? So you see, and this is 0. You see, since 0 volt to the NMOS, so NMOS will be off. I am applying VDD to the NMOS, so it will be on. So when it will be on, right, it will be like a short circuit approximately. So 0 will come here, output will be 0, right? And here it will be off, right? VDD and VDD means VSG is 0, so it will be off. This will be off. No current will flow through this. So the current will flow through only this path. In this case, F is equal to 0, right? So in this case, F is equal to 0. Let's take the next case. Next case is, okay, next case is A is equal to 1, B is equal to 0. And A is equal to 1 means this is 1, this is 0. Okay, that means this is 1, right? Since this is 0, this is off, and this is 0 means this is on, but this is 1 means this is off, right? So, but again this is 1 means this is on. This on means this 0 will go to the output, right? So F is equal to 0. So F is equal to 0, right? So next, see the next condition. Both are 1. Okay. Next condition is both are 1. So 1 means here it is 1, here it is 1, right? And here 1 means VDD, right? VDD, and this is also 1 is VDD. So this is 1 means VDD minus VDD is equal to 0. That means this is off, this is also off, right? So, and both of them will be on. When it is on, it will be like a almost short. So 1 will go to the output. So F is equal to 1. So F is equal to 1. Okay, so this is my truth table of this particular circuit. Okay, so if you see the truth table, right, for 0 0 I am getting 1, for 1 1 I am getting 1. Any of the input 1 and another is 0, then output is 0. So this is the truth table of XNOR. So answer is XNOR, right? So let's go to the next question. In this question, in the circuit shown, right, Vs is a square wave shown in the figure, right, with the maximum and minimum values are 8 volt and minus 10 volt respectively. Assume that diode is a ideal, right, and R1 and R2 is 50 ohm. This is 50 ohm. Is 50 ohm. The average value of output voltage VL. Okay, we have to find out. First thing, you should understand what is the ideal diode. Ideal diode, okay, there are two modes. One is forward bias. In forward bias, when the current, this is the current, okay, is greater than 0, then it will behave like a short circuit. Vd is equal to 0. Vd is nothing but this one. Okay, so it will behave like a short circuit. Okay, so in reverse bias, when Vd is less than 0, it will behave like a open circuit. This is my ideal diode. Okay, so now let us see. First thing is, when from 0 to t by 2 to t by 2, okay, I have 8 volt, right? Vs is 8 volt. 8 volt. Then I apply 8 volt, right, to a cathode, right? So it will be reverse bias, right? So the equivalent circuit will be Vs, okay. Then diode is reverse bias because I am applying 8 volt to the cathode, okay, and anode is ground. Initially it is 0, so Vd is negative, so it is reverse bias. Then there is a R1. R1 is equal to how much, guys? 50 ohm. Then I have R2 is equal to 50 ohm. This is nothing but VL. Okay, you can see clearly. Okay, the output VL is equal to R2 by R1 plus R2 into Vs is equal to 50 by 100 into Vs is equal to Vs by 2 is equal to 8 by 2 is 4 volt. Okay, so 0 to t by 2 I'll get 4 volt, right? So if you see the output, right, I'll get 4 volt, okay, up to t by 2. Let's see from t by 2 to t. Okay, so from t by 2 to t. Okay, in this case Vs is equal to minus 10 volt, right? Okay, so since I have minus 10 volt, right, and minus is applied to the cathode, so it will be forward bias, right? So it will behave like a short circuit, right? So if I have to plot the equivalent circuit, like a short circuit, right? So even if there is a resistance, it will not matter, right? R2 is equal to 50 ohm. This is also 50 ohm. This is VL, right? This is Vs. Okay, so in the negative time, or time t to t by 2 to t, and Vs is minus 10 volt. It will forward bias the diode. Okay, so my V output VL is equal to, okay, Vs, because it is short circuited, right? So the Vs will directly go to VL. Okay, it will equal to minus 10 volt. Okay, so if you see here, from T by 2 to T, I will get T, I will get minus 10 volt. So if I want to plot the output here, right, let me plot the output. From 0 to T by 2, I am getting 4 volt. Okay, 0, T by 2, this is T, and T by 2 to T, I get minus 10 volt. Okay, so it is asking find the average voltage of VL. This is VL. Okay, so VL average is equal to integration of 0 to T into VL dt into 1 by T. So average voltage of any waveform for a one period is 1 by T integration of 0 to T VL dt. So is equal to 1 by T. Okay, integration of 0 to T by 2, I am having 4 volt, 4 dt. Okay, plus T by 2 to T, I am having minus 10 dt. Okay, so is equal to 1 by T into 4 into T by 2, 4 into T by 2 minus 10 into T minus T by 2 is T by 2 only. Okay, so this implies T get cancelled. 4 by 2 minus 10 by 2 is equal to 2 minus 5 is equal to minus 3 volt. Okay, so this is my answer is minus 3 volt. So answer will be minus 3 volt. So what we have done, just when V in is 8 volt, we have calculated what is V output, that is 4 volt. When V in is minus 10 volt, we have calculated the output is minus 10 volt. Then we have taken the average. Okay, that will give me my average voltage. Okay, let's see the next question. So sir, this is a very good question. Okay, in this circuit shown, right, the breakdown voltage and the maximum current of the general diode is are 20 volt and 60 milliampere. Okay, so VZ breakdown is equal to 20 volt, and the maximum current that I can flow through the diode is IZ maximum is equal to 60 milliampere. Okay, value of R1 and RL are 200 ohm. This is 200 ohm. This is 1 kilo ohm. Right? What is the range of VI? Okay, that will maintain the Reynolds diode in on state. Okay, so for that, first we have to understand, okay, how a general diode operates. Okay, so let me just tell you briefly the IV characteristic of my general diode. So the general diode, all of you know, always operate in reverse bias. Okay, reverse bias. V cathode is positive compared to V anode. That is the first point. Second point is, if you see the IV characteristic, right? So until a particular reverse bias voltage, if you go on increasing the reverse bias voltage, the voltage will be almost very less, or I can say it is this is voltage, this is current. Okay, so if you go on increasing the reverse bias voltage, the voltage will go on increasing with a very small current. Okay, or you can say negligible current. Okay, so if you plot the IV characteristic of xenon diode, if you go on applying the reverse bias voltage, the voltage will go on increasing. After a particular point, okay, it will break down, then it will not increase at all. It will remain constant. This is known as V breakdown, VZ breakdown. Here it is given 20 volt. Okay, so the breakdown to occur, the current at this point, right, is called INE, right, or it's called I minimum current, right? After a particular minimum current called INE current, right, it started breakdown. After it breakdown, the voltage remains very constant, almost negligible change, or you can say voltage across the Zener diode remains almost constant after it get breakdown. Okay, and for breakdown to occur, I need a minimum current called knee current, that is I minimum. Okay, also thing is, if you go on increasing the current of generator, right, the power dissipation, right, power dissipation Pz is equal to Iz into Vz. Okay, so if you go on increasing the current, right, the power is increasing. Okay, so it time will come, right, it will bond, or there is a so thing is, for every generator diode, right, there is a maximum power that we can dissipate, because so every generator diode will be there in some packages, right, the packages will be optimized for a maximum power. So if I go on increasing the current, right, if you go on increasing the current, the power dissipation in generator diode will go on increasing. So it will reach a limit called Pz maximum. So I cannot increase current beyond the maximum power. So there will be a maximum current, okay, Iz maximum. After that, it will not support the maximum current, because the package is designed to dissipate only this much amount of power. Otherwise, it may get burned, or package may destroy. Okay. So what is the takeout from this explanation is, for my generator diode to operate as a generator diode, right, my current in the generator diode should be more than the knee current, okay, or less than the maximum current. Okay, so this condition is for making the generator diode breakdown. This condition is to ensure the maximum power dissipation in generator diode is less than the rated. Okay, so this is the concept. So this is very important, you have to remember. Okay, key for the diode to maintain on, right, this given, right, the diode will maintain on only if I ensure the current in the generator will be more than Ine and less than Iz maximum. This is the thing it is telling in a sentence. You have to maintain the diode in on condition. That means I have to maintain the current in generator between Ine and Iz maximum. Okay, so now let us solve the question. Okay, first question is, Iz minimum should be equal to Ine. Okay. But in the question, right, in this question, it did not give the Ine current, right? So in the question, it did not give the Ine current. So what you have to find, what you have to assume is equal to 0. So whenever in the question Ine is not given, right, you can take it as a 0 milliampere or 0 ampere. Okay. So and what is the minimum current in generator? This is my source current. This is my load current, right? Load. So Iz minimum is equal to I source minimum, right, minus I load maximum. I maximum, right? Because when the current in generator will be minimum, the case where source current is minimum and load current is maximum, so minimum minus maximum will give me my minimum current. Okay, this is the condition for minimum current. Okay, so let us so Iz minimum is 0, right? So Iz should be greater than or equal to Iz minimum. Okay, this implies I source maximum, I source minimum minus IL maximum should be greater than equal to Iz minimum is 0, right? What is Is minimum? In this case, V in maximum minus Vz by R. V in minimum or Vi minimum minus Vz by to get minimum current, I need maximum R, but it is given R is constant. Okay, already it is given R is constant. Okay, so I need not to bother about the variation of R1. So ideally, the minimum current will be Vz minimum minus Vz by, sorry, the Is minimum will be V input minimum voltage minus the Vz, this is Vz, right, by R1 maximum. But here R1 is fixed, so I will take R1 directly. Okay, if R1 would have been varying from minimum to maximum, I will have to take R1 maximum. Okay, minus I load maximum. I load maximum is Vz by RL minimum. But in this question, RL is fixed also, so I will take RL only, because IL maximum will be Vz by RL minimum. So Vz by RL minimum will be my load current maximum. Okay, but since RL is fixed, so I can take Vz by RL should be greater than equal to 0, right? So let's apply Vi minimum minus Vz is 20 volt, okay, by 200 ohm equal to, I can say, or greater than equal to, I can say, Vz is 20 by 1 kilo ohm, right? So Vi minimum minus 20 should be greater than equal to 20 into 200 by 1k. This implies V in minimum should be greater than equal to 20 plus 4. So should be greater than equal to 24 volt. V in minimum, right? This is what we got from the equation. This one. This equation, if you know, I can get the V in minimum. Okay. So now my Iz should be less than equal to my Iz maximum, right? What is Iz? Iz maximum current is V in maximum, right? Or I can write it here. What is the maximum current in a genre is I source maximum, right? I source maximum minus I load minimum will give me my current in genre, that is maximum, right? Less than equal to Iz max given in the circuit is 60 milliampere, right? Again, I am repeating, the maximum current in genre is the source current maximum minus load current minimum, right? Because maximum to minimum, if I subtract, I will get maximum, right? In exam, you will get confused. To if you want the genre current maximum, I have to subtract maximum source minus load minimum, not load maximum. I am repeating, not load maximum, because maximum minus minimum will give me my maximum genre diode current. Okay. So what is Is maximum, guys? Is V in maximum, right? Minus Vz by, actually it should be R in minimum, but R1 is already fixed, so I will put R1 only. Similarly, IL maximum is Vz by RL maximum, but RL is already also fixed, so I will put RL. If RL is changing, I have to put RL maximum to get I load minimum current. Okay, is equal to 60 milliampere. Okay, so again I am telling, to get I source maximum current, right? This current is maximum. What I want, the V input should be maximum and R1 should be minimum. But in the question, R1 is already fixed, so I will take R1 as it is. Similarly, to get the load current Vz by RL, right, minimum, the RL should be also maximum, right? Vz by RL maximum will give me my IL minimum. But since the load already fixed 1 kilo, so I will take 1 kilo. Okay. In another situation, another condition where R1 also is varying, RL also is varying, in that case, you have to be little precocious. You have to take little precaution. Okay. So Vi maximum minus 20 volt is Vz by 200 ohm. Okay. Minus 20 volt divided by 1k. Since it is fixed, I am taking fixed. Okay. If it would have been varying, I have to take R1 minimum and RL maximum. Okay. Less than 20, less than 60 milliampere. This implies V in max minus 20 divided by 200, okay, is equal to, this is 20 by 1k, 20 milliampere. So 60 plus 20 is equal to 8 milliampere. 80 milliampere. Okay, so this implies Vi max minus 20 less than equal to 80 into 200 is 16, right? This implies V in max less than equal to 20 plus 16 is equal to 36 volt. Okay, so V in should be more than 24 and less than 36. Okay, see, this should be answer B, right? So the most important point in order to solve this question is we have to know the general current should be between INE and IZ maximum. Another thing is these two equation, right? The IZ minimum is minimum source current minus maximum load current. Similarly, IZ maximum is maximum source current minus minimum load current, because generally students get confused at this particular two equation. Okay, let's see the next question. Okay, so in the circuit shown, right, the threshold voltage of each NMOS transistor is 0.6 volt. Okay, so guys, VTH is equal to 0.6 volt. Okay, ignoring the effect of channel length modulation, okay, and body bias, the value of Vout1 and Vout2 respectively in voltages. Okay, so actually all are NMOS, right? All are NMOS, and we know in a NMOS transistor, right? So if you take a NMOS transistor, right? Generally, drain voltages are more compared to source. So I can assume that this will be drain, this will be source, and this will be drain, this will be source, right? Similarly here, this is drain, this is source. For this transistor, this will drain, this will be source. For this transistor, this will be drain, this will be source. Okay. So in order to solve this question, we have to understand one particular concept. Okay, very easy concept. Thing is, guys, you see, suppose I am applying this is my VDD, right? And input also I am applying VDD, right? Suppose so, since my input is VDD and I am applying drain voltage also is VDD, right? Understand, I am applying VG is VDD and VD also VDD. Definitely, my transistor is almost on. Suppose let's take a capacitor, okay? So we know there is capacitor in the source point, drain node, and gate node. So there is a gate capacitance, source capacitance, and then so every node there is a intrinsic capacitor. Okay, that is not shown. Okay, so there is a capacitor to ground. This is nothing but an intrinsic capacitor, which is nothing but source to body capacitor. Okay, what is my question is, what will be the maximum voltage this source can reach? This is the question. So if you can understand this question, then you can easily solve these two questions. Okay, so try to understand. Okay, initially everything is not there. Initially there is no current. When I apply VDD, what will happen? There will be some current flow, right? So because when VGS is greater than VTH, right, my transistor will on, right? When my transistor will on, the current will flow. Since the current will flow in the capacitor, the voltage will start rising, right? So you see, now Vg minus Vs is Vgs is equal to Vgs, right? Vg is equal to constant, it is VDD, right? Since my gate is on, okay, what is happening to my source is getting increased. Okay, so what will happen to my VGS? Getting decreased. Okay, so I know for my transistor or MOSFET to on, I need a minimum gate to source voltage, that is called VTH or threshold voltage. Okay, if my gate to source voltage is less than threshold voltage, my transistor will be off, there will not be any current. Okay, so initially my source is at 0. When I apply a VDD at gate, what will happening? There is some current flowing. My source voltage will start increasing because the capacitor will start charging. So the source voltage will go on increasing. Then VGS is nothing but gate minus source will go on decreasing. Okay. So how long this will take place? This will take place, okay, when source is increasing, VGS will decreasing, right? Then it will go on in like this until it reaches VGS is equal to VTH. Okay. After that, what will happen? VGS will be less than VTH. Then there will be no current, So the capacitor also cannot able to charge. Okay. So the source voltage will go on increase and VGS will go on decreasing until my VGS will be equal to VTH. After that, what will happen? My transistor will be off. Okay. So this implies VD minus VS is equal to VTH, right? Because when I increase source, VGS will decrease. It will go on decreasing till it reaches VTH. Okay. Now this implies V source can go maximum up to VDD minus VTH. Right? This is the important concept that we have to understand. Okay. Again, I am just briefing. Initially, the capacitor is uncharged. When I apply a VDD, right? VGS will be VDD, right? Initially, there is no charge. When I apply a gate voltage VDD, at that time, source also 0. So initially, VGS is VDD. Okay. Since VGS is VDD initially, current starts flowing. When current starts flowing, the voltage of the source will be go on increasing. Okay. And VGS will be decreasing. That means current also will be decreasing, right? Because when VGS is decreasing, current will decrease, right? So because I is proportional to VGS minus VTH square when in saturation. Okay. So since VGS is decreasing, current will decrease. When VGS will reach VTH, right? The current will be 0. There will not be any charge. There will not be any charging in the capacitor, right? So the VGS will go on decrease until it reaches VTH. Up to that point, the current will flow and source potential will increase. Once it reaches VTH, then the source potential will remain constant because there is no current. Okay. So my source will be VDD minus VTH. Okay. You come to this question now. You see, now I am applying gate is equal to 3 volt, right? This is my drain. So let's go to the next. Okay. You see this one. Okay. This is my drain. This is my source. Okay. Suppose you know there is a capacitance, right? Already there. The capacitance is called intensity capacitor. Okay. So which is not shown, but it is there. Okay. So what will happen? This potential will rise. When Vs will reach Vg minus Vth, right? At that time, Vgs is nothing but okay. So initially the current will flow, right? And it will charge the capacitor up to Vs is equal to 3 minus Vth. Okay. After that, what will happen? Vgs is equal to 3 minus Vth is equal to Vth only. Okay. Then Vs is equal to 3 minus Vth. VGS is equal to 3 minus VTH is equal to VTH. So after that point, the capacitor will the transistor will be off and source voltage remain constant at 3 minus VTH. Okay. So what is VTH here? Is 0.6 volt, right? So this voltage will go up to 3 minus 0.6 is equal to 2.4 volt, right? Now you see this transistor. For this transistor, okay, Suppose this is M1, this is M2. For M2, okay, Vg is equal to 2.4 volt, right? So it will be on. So when my V out 1 is nothing but Vs2, is nothing but Vs2. Okay, will reach 2.4 minus Vth, right? At that time, Vgs2 is equal to 2.4 minus 2.4 minus Vth is equal to Vth. Then what will happen? This M2 will stop conducting. Okay, so my source potential will remain same at 2.4 minus Vth is equal to 2.4 minus 0.6 is equal to 1.8 volt. Okay, this is the answer for the first figure. Okay, you remember this concept. The current will flow, the source node will go on increasing until it reach Vg minus Vth, until it will reach Vg minus Vth. Okay, this question, you see, similarly there is a intrinsic capacitor, okay, there which is not visible, right? What will happen, say, initially, since this is my drain, this is my source, the current will flow, right? This potential will rise up to 3 minus Vth. Okay, so this will be rising up to 3 minus Vth. Okay, now for this transistor also, since my source potential is 3 minus Vth, it will be on, right? Again, this will charge up to 3 minus Vth because it will charge up to Vg minus Vth. After that, it will be off. Okay, also this you see, for this transistor, drain is 3 minus Vth, it will be on, current will flow, again it will charge up to 3 minus Vth, right? After that it will be off, so it will be 3 minus 0.6 is equal to 2.4 volt. Okay, so for this question it will be 2.4 volt. Let's see, 1.8 and 2.4, this is the answer. Okay, so this is very important, this thing you should remember. Okay, when source voltage potential will increase, then Vgs will decrease. When it reaches Vth, at that point the transistor will stop conducting, then the source potential will remain same at that particular point. Then Vs is equal to Vg, here it is Vg minus Vth. Okay, so here I put Vdd, that's why I put Vdd. Otherwise, remember this one, Vs is equal to Vg minus Vth. Okay, after this it will stop conducting. Then using this concept, this can be easily solved. Okay, now consider a long channel MOSFET. Consider a long channel MOSFET with a channel length of 1 micrometer and width is equal to 10 micrometer and length is equal to 1 micrometer. Okay, the device parameters are: the acceptor concentration is 5 into 10 to the power of 16 per cm3. The mobility of electron is equal to 800 cm square per volt second. COX is 3.45 into 10 to the power of minus 7. Right? The threshold voltage is 0.7 volt. Okay. Calculate the drain saturation current for gate voltage of 5 volt. Okay. So Vg is equal to 5 volt. Okay, guys, we know the saturation current ID set in a NMOS enhancement MOSFET is half Vn COX W by L VGS minus Vth whole square. Okay, neglecting the channel length modulation. Okay, see guys, this is a very easy question, right? Put the numbers, get the answer. So this question will be solved by everyone. So this will not give you any extra additional rank in the examination. So in examination, to get a better rank, you have to solve all the difficult questions. That will be the rank booster questions. These are the common to all people. So they will not boost any rank to you. Okay. 800, okay, cm square by volt second into Cox is how much, guys? Is 3.45 into farad by cm square into 10 power of -7. W is 10 micrometer, length is 1 micrometer, double value 10 into VGS is how much? 5 volt minus VTH is how much? 0.7 volt per square. Just put the number, you can get the answer. So let's use the calculator, guys. 0.5, okay, 0.5 into 800 into 3.45 into 10 power of -7, okay, into 10 into 5 minus 0.7, 4.3 square. So I got 25.5 milliampere. This is a straightforward question, right? So no need to bother. Okay. So let's see the next question. So in the next question, what it is asking, in the circuit shown, right? Vs is a waveform of 10 volt square wave. Period t is equal to 4 millisecond. Okay, and R is equal to 500 ohm. C is equal to 10 microfarad. Okay, the capacitor is initially uncharged at t is equal to 0. The diode is assumed to be ideal diode. Okay, which I explained already. What is the ideal diode? The voltage across the capacitor at time t is equal to 3 millisecond. Okay. So guys, you see, time period is equal to 4 millisecond. Okay. First thing is, for 0 to t by 2, okay, for 0 to t by 2, okay, Vs is equal to what, guys? 10 volt. So it will forward bias the diode. So it will behave like a short circuit. So the equivalent circuit will be how much, guys? Will be short, right? Vc, okay. C R, this is C, this is Vs is equal to 10 volt. Okay. So this is a simple RC circuit. Okay. From 0 to 2 t by 2, t by 2 is nothing 0 to for 2 millisecond, right? The capacitor will charge, right? You know, Vc t is equal to, okay, V infinity plus V0 minus V infinity into it power of minus t by RC. Okay. Here V infinity is nothing but 10 volt plus 0 minus 10, okay, for minus t by RC. Simply 10 into 1 minus e power of minus t is equal to how much, guys? I want the voltage at 2 millisecond, right? 2 millisecond divided by RC. RC is nothing but how much? 500 ohm into 10 micro. So it is how much? 5 millisecond, right? 5 millisecond. So it is equal to 10 into 1 minus e power of minus 2 by 5. Okay. So let's use the calculator and see the how it is coming. 10 into 1 minus e to power of minus 2 divided by 5. I got 3.29 volt, right? Okay. From 0 to t by 2, the capacitor will charge, right? And it will reach a point called 3.29. Okay. What will happen after that? After that, you know, Vs is minus 10 volt. So when I apply a minus 10 volt, right? You see, So at T by 2, Vc is equal to 3.29 volt. Then I am applying from T by 2 to T, okay, nothing but 2 millisecond to 4 millisecond. I am applying minus 10. So when I apply minus 10, okay, at that point I have capacitor is equal to 3.29. So the diode will be reverse bias because V anode so just at T by 2, okay, V anode is equal to minus 10, V cathode is 3.29. So it is reverse bias. Diode is reverse bias, right? So what is the equivalent circuit? Okay. So minus V is equal to minus 10. This is from T by 2 to T. Okay. So Vc. So you see from T by 2 to T, since diode is open circuit, the capacitor won't able to charge or discharge. So the voltage across the capacitor will remain constant from T by 2 to T because there is no way to charge or discharge the capacitor. Okay. So this will remain constant at 3.29. Okay. So in the question it is asking the voltage in the capacitor at 3 millisecond. That means from 2 millisecond to 4 millisecond, my voltage is constant. So at 3 also, my voltage is constant. So at 3 millisecond, my voltage will be 3.29 volt, which is same at T by 2, which you calculated in the previous slide. Because after this, my diode will be open, the voltage in capacitor will remain constant up to T by 2 to T. Okay. So answer is 3.29. Next question is, yes, you see a CMOS inverter, right? What is first draw a CMOS inverter before going to that. CMOS inverter is nothing but consist of one PMOS and one NMOS. I am applying a input V in. Okay. Here I am applying a output V out. Okay. This is my VDD. VDD. This is my ground. Okay. So showing that have a midpoint voltage Vi equal to VDD by 2 in the figure. I am applying Vi is equal to VDD by 2, and at that point V output is equal to VDD by 2. So V in is equal to VDD by 2, V out is equal to VDD by 2. Right? Okay. So VDD is equal to 3 volt. Now given everything, right? Mu1 CUX, VTN, Mu P CUX, VTP. Then we have to find out double by L N to the double by L P. So I have to find out double by L N by double by L P, right? So first thing you try to understand, guys, since my input is changing, so the input, no, first thing is when V in is equal to 0 volt, okay, what will happen? This is NMOS M1, M2, M2, right? NMOS will be off because gate is 0, right? So first you remember for a transistor, NMOS VGS should be greater than equal to VTH to make it on. For PMOS, VSG should be greater than equal to VTH mode. Okay. When I apply 0 volt in the input, VGS is equal to 0. So M1 will be off. M1 will be off and M2 will be on because VSG is VDD minus 0 is 0. So M2 will be on. M2 will be on. So what will happen? When M2 will be on, so it will be like a almost short circuit. This is very high resistance, so almost VDD will come to my output. So my V out is equal to VDD. Similarly, when I apply V in is equal to VDD, right? What will happen? M1 is VGS is VDD, so it will on. M2 VDD minus VDD is 0, so M2 will be off. So M2 will be off means this will be cut. M1 will be on, so it will be like almost a short circuit. So ground will come to V out. So V out will be 0, which we have seen. When V in is equal to 0, we have seen output is VDD. Here we have seen. When V in is equal to VDD, my output is 0. We have seen. In between the transient, right? The output will go from high to low. Okay. So in this particular case, right? At this midpoint, right? In this particular case, V in is equal to VDD by 2, right? So let me draw the VDD, VO, VIN. Okay. The NMOS, you take NMOS. Okay. V in is equal to VDD by 2. Okay. V output also VDD by 2. Okay. So VGS is equal to VDD by 2 and VDS is equal to VDD by 2. Right? Given V in VDD by 2, V out also VDD by 2. So VDD by 2. It implies VGS is greater than plus VDS is greater than VGS minus VTH. So my NMOS is in saturation. Similarly, my PMOS, okay, you see VSG is equal to VDD minus VDD by 2 is VDD by 2, right? VSD is equal to VDD minus VDD by 2 is equal to VDD by 2. Okay, for this also VSD is greater than equal to VSG minus VTH more. So PMOS also is in saturation. So at this particular point, right, my PMOS and NMOS both are saturation, right? So we have to apply the current. Okay, since the current in the branch is same, right, same current flowing through the PMOS and NMOS. So IN is equal to IP, right? IN is equal to nothing but a transistor is in saturation, nothing but half mu n COX double by L of NMOS into VGS minus VTS. Is VGS is how much? VDD by 2 minus VTH rho whole square is equal to IP is how much? Half mu P into COX into double by L P into VSG minus VTH whole square. Here VTH is VTH mode. Okay, so let's put the value. Half mu1 CX is 100 micro ampere by volt square into double by L N into VD by 2 is 3 volt by 2 minus VTH is 0.7 is equal to half mu P is 40 micro, right? 40 into 10 power minus 6 into mu1 CX is given, okay, into double by LP into BAG is 3 by 2 minus VTHP mode is 0.9 volt square. Okay, so if you solve this question, right, double by L N divided by double by L P is equal to this by this 20 into 10 micro into 1.5 minus 0.9 rho whole square divided by 50 into minus 6 into 1.5 minus 0.7 whole square. So let's use the calculator. Okay. So 20 into 10 power of minus 6, okay, into 1.5 minus 0.90 whole square divided by 50 into 10 power of minus 6 into 1.5 minus 0.70 whole square. So I got 0.225. Okay, so the answer will be 0.225. Okay, so one thing you have to understand, when V in is equal to VD by 2, VR2 is equal to VD by 2, transistor PMOS and NMOS both are in saturation. Then since the current is same, I have to equate the current of transistor NMOS and PMOS. Then I will get the ratio between the double by L of both of the transistor. Okay, let's go to the next question. So in the next question, what it is asking, you see, in the circuit shown, okay, the threshold voltage of PMOS is VTP and NMOS is VTN, right? Are equal to 1 volt. VTN equal to VTP more equal to 1 volt. Okay. All the transistors have the same output resistance RDS of 6 mega ohm, right? The other parameters are mu1 Qx given 60 microampere per volt square, double by L is 5, Vp Qx is 30 and double by L is 10. Okay. Then ignoring channel length modulation, that means lambda, right? On body bias, the gain of the circuit, okay, is, first thing is, ignoring channel length modulation means R0 is equal to 1 by lambda ID. You have to ignore. Okay, it means R0 is very, very high. You can say infinity. Okay, that you have to ignore. Okay, sorry. So that part, okay, ignoring channel length modulation. Okay, given my output resistance is 6 mega ohm. Okay, so the thing is, I have to find the gain of the circuit. Okay, see, the resistance looking up is nothing but RDS P, right? The resistance looking down is RDS N. Okay, and what is the gain in the circuit, guys? Gain is equal to, okay, because I apply input to the NMOS transistor, right? So if I apply input V in, then the current will be GM into V in. Okay, if I want to, okay, so my V out will be, what is the small signal current, will be equal to GM into V in. Okay. What is the resistance here? Is R DS of PMOS parallel to, looking below is RDS of NMOS. Okay, so it will equal to minus GM V out by V in is equal to minus GM into RDS P is equal to RDS N, RDS parallel to RDS. Okay, is equal to minus GM by 2 RDS. Okay, so now since RDS is given, what we have to find out is GM nothing but transconductance of the NMOS transistor, right? So if I able to find the transconductance of my NMOS transistor, I can able to find the gain, right? Because when I apply input, it will create a small signal current, that is GM into Vn. When the small signal current flow through my output node, it will generate a voltage, nothing but current into resistance. Resistance is, resistance looking upward is rds p, direction looking downward is rds n, then it will be rds p parallel to rds n, then my gain will be minus gm into rds parallel to rds, it will be minus gm by 2 into rds. So our aim is to find out the transconductance of my input transistor. Okay, so we know for finding transconductance, I have to know either the current, DC current. So for GM will be equal to, okay, we have to find GM. Okay, we have to know either the DC current or DC gate to source voltage. Okay, since here DC gate to source voltage is 0, right? So because it is feeding current, okay, so I have to find out the current. Okay, ID. So how to find ID? For that, we have to see this. Okay, see this is VDD minus VSGP minus VSGP. Okay, so if you put a KVL here, okay. So now how to find ID is my aim. Okay, so VDD minus VSGP minus VSGP, right? Because all the transistors are identical, right? So because VDD minus VSB, SGP, since the same current will flow, the same potential will rise from here to here also, right? So equal to 0. This implies VSGP is equal to VDD by 2 equal to 4 by 2 is equal to 2 volt. Okay. See what I am telling. This is the source. This is gate. Again, this is source of this transistor. This is gate. Okay. Since the same current is flowing, okay, current is proportional to VGS minus VTH square in saturation. So since the same current is flowing to the branch, so there should be same VGS, right? Since same VGS, so I applied same VSGP and same VSGP. Okay. So no, so the conclusion is the VSGP is 2 volt. If VSGP is 2 volt, the current in the left branch I. Okay, what is I? I is equal to half UP COX PPCOX double by L of PMOS into VSG minus VTP mode rho whole square. Okay, simplifies my current in the left branch I, okay, equal to half into mu PPCOX is 30 microampere, 30 micro into double by of L is 10 into 10 into VGS minus VTH whole square. VGS is nothing but 2 volt, and VTH is 1 volt. Okay, so 2 minus 1 whole square. So it gives me how much, guys? It gives me 2 get cancelled and 5 2 5 100. So 150 microampere. Okay, so the current here is 150 microampere. You see, suppose this is M1, this is M2. Okay, for M1 and M2, since gate to source voltage is same. Okay, since gate to source voltage is same, and my current ID proportional to VGS minus VTH whole square. Okay, neglecting the channel length modulation. If channel length modulation would have been there, it should be 1 plus lambda VDS. Okay, in VDS of M1 and M2 will be different, then current will be different. So that's why smartly it is telling there is no channel length modulation. If channel length modulation would have been there, if there would have been channel length modulation, the ID will be different because VDS of M1 will be different from VDS of M2. That's why it said there is no channel length modulation. In that case, the current solely depend upon gate to source voltage. Since gate to source of M1, VGS of M1 is equal to VGS of M2. Okay. So the current in M2 will be equal to current in M1 is equal to 150 microampere, right? Clear? So that's why it is saying neglecting the effect of channel length modulation. Okay, this point is very important. Then only the current will be 150 microampere. Now, since the same current will flow through my input transistor, okay, the GM of input transistor will be, okay, root over of 2ID mu n Cux into double by L, okay, is equal to root over of 2 into 150 micro into mu n Cux is how much? Is 60 micro into double by L is 5 into 5. Okay, see what will will get? 10, so how much will get? Will get micro will get cancel. Okay, 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 we'll get 300 micro will come outside. We'll get 300 microampere per volt. Okay, 300 microampere per volt. Okay, this is my GM. Now AV is equal to minus GM by 2 into RDS is equal to minus 300 into 10 power minus 6 by 2 into RDS is how much, guys? 6 mega. 6 into 10 power of 6. So that cancel. So how we got minus 10 units here. We got 900. Okay, so this is my answer. So let me just brief you. First thing is, we know when I apply input AC, it will generate a current minus GM into VM. Okay, then current into resistance is my voltage. So I did current into resistance. Then my gain will be GM by 2 into RDS. Since RDS I know, the main important aim is to find the GM. For finding GM, I have to know the current, DC current flowing through my input transistor. So for finding DC current to the input transistor, what I have done, I calculated the current through the left branch. Okay, that have come 150 microampere. Since my left branch current equal to right branch current, because BGs are same, so same current will flow through my right branch. After knowing the current, I calculated the transconductance. Then my gain will be minus GM by 2 into RDS. Okay, this is the solution. Now, the last question I think is, in the circuit shown, okay, VI is equal to 0, V1 is equal to 0, V2 is equal to VDD, right? The other relevant parameters are mentioned in the figure. Okay, ignoring the channel length modulation and body effect, find I out in milliampere. Okay, guys, you see, first thing is you have to write the equation of I out. ID is equal to half mu n or mu p Cux double by L into VGS minus VTH whole square into 1 plus lambda VDS. Okay, since it says ignore the channel length modulation, so this factor I have to ignore. Okay, so this is not there now for this particular question. Okay, now you understand my ID, okay, is proportional to double by L, right? Also is proportional to VGS minus VTH square, right? So now come to this question. Okay, suppose 1 milliampere current is there, right? This 1 milliampere is current flowing, right? It will generate a voltage so that 1 milliampere current will flow through this transistor. Since for this transistor, right, suppose this is M1, this is M2. Okay, gate is connected, source is connected. So VGS of M1 is equal to VGS of M2. So current I into M1 by current I into M2. Okay, will be, see, since VGS is constant, this is gone, so will be double by L of M1 by double by L of M2. This implies current I in M2 is nothing but this transistor, right, equal to IM1 into double by L of M2 divided by double by L of M1 is equal to 1 milliampere, okay, into M2 is 3, right, 3 by 2. So 3 by 2 is how much? 1.5, right, 1.5 milliampere. Okay, this is 3 by 2. Now you see the current here is I M2 is equal to 1.5 milliampere. Okay, now you see the current have a path, maybe going like this or going like this. Two paths is there. But thing is, for this transistor, right, V1 is equal to 0. That means Vg is equal to 0. And Vg is equal to 0, transistor is off. This is cut off. That means total current will flow through this transistor. Let this transistor will be M3. Okay, so IM3 is equal to IM2 is equal to 1.5 milliampere, because the transistor V1 is 0. So this transistor will be off. So the total current will flow through transistor M3. Okay, now you see, since both are connected in series, the same current will flow through transistor, suppose M4. So is equal to I M4. Okay, now you see, since this is, let us take M5. Okay, since by M4 and M5 VGS is same, right? Gate is connected, source is connected. So VGS of M4 and M5 is same. So now VGS of M4, this is M4, this is M5. Okay, M4 is equal to VGS of M5. So I M4 divided by I M5 is equal to double by L of M4 by double by L of M5. Okay, because VGS is constant, same. So sorry, it has erased. I of M4 by I of M5 is equal to double by L of M4 divided by double by L of M5. Since VGS is same for both, since VGS is same, current proportional to double by L only. So now I of M5 is equal to IM4 into double by L of M4 is how much, guys? Is IM5 is equal to IM4 into double by L of M5 divided by double by L of M4. Okay, is equal to, what is IM4? IM4 I have calculated is nothing but 1.5 milliampere. So 1.5 milliampere into M5 is 40 divided by 10. So 15 into 4 is nothing but 6 milliampere, right? They got 6 milliampere in output current. So this is the answer. Okay, so simple steps. First thing is you have to understand ID proportional to double by L and VGS by MVT square. When VGS will remain constant, then it is proportional to double by L. Then simply we have to just calculate like this. Okay, so this is the question. So I think that's all of you. That's all. Thank you guys, all of you, for the patient listening. Okay.